Okay, so we are going to learn how to rationalize the denominator, and it's pretty straightforward. So let's get into it. So we have, let's just say, a very random case. So I have the root to the kth power of a over b, but I can write this as the root. I can split it up, right? Now, what if I just don't like this root in the denominator? I'm going to rationalize it. So I actually multiply the top and bottom by this, right? And what that gives me is when I multiply these and it has the same value in here. So right now it's k, which is just abstract. It could be a 2, which is just the normal root. They just extract the radicand. They just explicitly take out b. So then what we get is something over b. So that's what we're wanting to do. But these are both the same root of the same power. So then I can group them to a, b, to k. And what I need in this case is that b is always bigger than 0. So it has to be bigger than 0 because it can't be 0, because if I divide by 0, it's not going to work. And then I also need a is greater than or equal to 0. So a in this case is it just has to be at least 0 because I can't take the roots of something less than 0. And that's pretty much it. So I mean, in general, there is explicit cases where you can have the negative integers to get the negative roots, but we're not going to deal with that. So now let's say I have something a little bit more complicated. I have a bracket a minus the root of b. Well, how would I get rid of that? We've shown how to get rid of it when there's just one term, but now I have two terms, an a and this negative root. I'm going to multiply by something called the conjugate. And the conjugate is just the opposite sign. And I do the same to the top and the bottom. And when I multiply this out, we can see it's just a difference of squares. So the difference of squares gives us this really straightforward thing, which is just it's a squared minus whatever's in the radical. And if you need practice learning about the difference of squares, you just have to go find the video on it and watch that. It's pretty quick. But you can just follow this out and you get a squared plus a times root b minus a times root b, and then you have minus times positive root b, so you get the b out. Okay, so we've gotten that down. So I can actually just show it. Why not? Let's just show it. So what if I had two roots? I have the minus root of u and the root u minus root v times the conjugate. And what that gives us is I have root u times root u, which is just root u squared. And then I have root u times root v. And then I have negative root v times root u. And then I have the negative times the positive, root v, and I have two of them, so I square it. I put brackets around that. So that squared is just u. The order of these doesn't matter, so these two cancel out, right? And then I just have the minus, and this squared is just v. So some of my letters are from writing in cursive. So the V is cursive and the Z's are cursive. So every once in a while you see I'll do a funny looking letter. It's either because I write in cursive at times or it's a Greek letter. But I'll say as I'm doing it. But that's how you rationalize the denominator.